In today's lesson, we are going to go over how to reduce a complex fraction, simplify it as far as we can. So our steps are, we're going to start by getting a common denominator on the top of the fraction and creating one fraction for the numerator. Do the same thing in the denominator, and then we're going to same change flip, just like we did on our multiplication and division day. Our first example, go ahead and take a minute and write that down in your notes. You can see in the numerator we have a fraction and then minus 1. So I'm going to go ahead and rewrite that 1 as a fraction, 1 over 1. And then in the denominator we have two fractions already given. So we're going to start in the numerator and we are going to find an LCD for these two fractions. The least common denominator here, we have x squared and 1, so our LCD has to be x squared. Now to fix our fractions, the first one's good to go, it has that common denominator. But I need to multiply the second fraction by x squared on top and bottom. When I do that, I'm left with 1 over x squared minus x squared over x squared. And since our denominators are now the same, we can combine this into one fraction. So that would be 1 minus x squared all over x squared. And we'll leave that alone for now. It's one fraction, so we can move on to the bottom. In the denominator, we don't have anything that we can factor for either one of these denominators here. So what we're going to do is write our LCD as 5 and x. Multiplied together. So this first fraction is going to need x to become that LCD. And whatever I do to the bottom, I also have to do to the top. I went ahead and put parentheses around this x plus 6 because I have to distribute that x to both things. Second fraction, I'm going to need a 5 on top and bottom. And now I'm just going to clean this up a little bit. So x times x is x squared. Plus x times 6 will give us 6x over 5x, plus 5 times 1 is 5, and then 5 times x is just 5x. So now that we have the same denominator in both of these fractions, we can combine this into one fraction. So we'll have x squared plus 6x, and then plus 5 all over 5x. So now I have one fraction in the numerator, and then one fraction in the denominator. When I get to this point, I can go ahead and treat this as a division problem where I would keep the numerator the same, change this to multiplication, and flip. So we're multiplying by the reciprocal. When I write that out, (5x) would go on top, x squared plus 6x plus 5 on the bottom of that second fraction. The first fraction stays exactly the same. And now our last couple of steps are going to involve just factoring where we can and then simplifying. So 1 minus x squared, hopefully you look at that and you know that that's not in standard form, and we want it in standard form when we're factoring. So we're going to flip that around. Negative x squared plus 1, and then we're going to factor out a negative 1. And we'll have x squared minus 1 inside. With x squared minus 1, hopefully when you look at that, you can see that's going to be difference of squares right away. So we're going to write that as x plus 1, x minus 1. And then that negative 1 is just hanging out from where we pulled it out earlier. So don't forget to write that. So we're going to write negative 1, x plus 1, x minus 1 for that first numerator. The x squared on the bottom, we can't do anything with that, so just leave it alone for now. 5x, can't do anything with that, but then our trinomial we can factor. So we're looking for two numbers that multiply to give us 5 and add to give us 6, and those two numbers are 5 and 1. So we're going to write x plus 1 and x plus 5. Alright, now here comes the fun part where we can start crossing things out that are the same top and bottom. So we have an x plus 1 on top and an x plus 1 on the bottom. We can get rid of that. No other binomials to get rid of here, but we do have a monomial of x and then x squared, so we can reduce that, leaving us with just an x on the bottom no x's on the top. So the way that we would express our final answer is a negative 5 and then x minus 1 over, we're just left with one x on the bottom, so x and then x plus 5. So here's our second example. Working the same way, we have x squared over 3 and then minus x. I'm going to go ahead and write that as a fraction, so x over an understood 1. 15 over x on the bottom plus 5 over an understood 1. Start with the numerator and let's get an LCD. So our current denominators are 3 and 1. Least common denominator there is just going to be 3. The first fraction's good to go. The second one just needs to be multiplied by 3 on top and bottom. So we're going to have x squared minus 3x over the LCD of 3. Leave that alone for now and let's go to the bottom. So in the denominator, we have an LCD of x because all we have here is x and 1. First fraction's good to go. The second fraction needs the x. So we'll give that to numerator and denominator. We'll have 15 plus 5x over the LCD of x. So now we have one fraction in the numerator, one in the denominator. We are ready to same, change, flip. So we'll keep the first fraction the same. Change division to multiplication, flip that second fraction. So now we're going to see if we can factor anything and simplify further. X squared minus 3x, I have a GCF of x there. Denominator will stay 3. Numerator, the second fraction, is going to stay x. And then the denominator, I'm going to rewrite that in standard form. So 5x plus 15, and then take out a GCF of 5. And we're left with x plus 3 inside the parentheses. All right, so at this point, it looks like there's nothing that will reduce. So we'll go ahead and just write this all in one fraction. We have x times x, which is x squared, x minus 3, and then 3 times 5 is 15 with an x plus 3. And that is our final answer. Our final example is dealing with a bunch of binomials. So when we write this out, it's going to work the same way as the last two problems. We're going to look for an LCD in the numerator and in the denominator of this complex fraction. Starting in the numerator, we have binomials that cannot be factored any further. So our LCD will have to include both of those binomials, the x minus 5 and the x plus 3. So the first fraction, to fix it, we'll need an x plus 3. Whatever I do to the bottom, I'll also have to do to the top to keep this equivalent. And I go ahead and put parentheses around this binomial to remind myself I'm going to have to FOIL this out eventually. The second fraction, I'm going to need an x minus 5 on the bottom, so also give that to the numerator. And let's just go ahead and clean this up while we're here. So x times x is x squared plus 1x plus 3x, and then 3 times 1, which is a positive 3. And then the second fraction, we just have to distribute 2 to x minus 5, and it's a positive in between. So plus 2x minus 2 times 5, which is 10. Combine all of these like terms, which you can. We have an x squared. Then we have x, 3x, and 2x. That'll give us a total of 6x. And then positive 3 minus 10, which will be a negative 7. Over your LCD, which is x minus 5 and x plus 3. Now let's forget about the top for a second. Let's go take care of the bottom, the same idea. If you notice, the LCD is going to be the same because we have the same two binomials showing up here. But the first fraction is going to need x minus 5 this time, top and bottom. The second fraction needs x plus 3, top and bottom. Let's go ahead and distribute what we have in the numerator. So we have x squared minus 5x. Sorry, you couldn't see any of that. There you go. X squared minus 5x plus x squared plus 3x. We have x squared plus x squared, which is 2x squared. Negative 5x plus 3x would be negative 2x over the LCD. All right, now we're ready to same change flip. So we're going to have x squared plus 6x minus 7 over LCD times the reciprocal, so x minus 5 and x plus 3 go on top. 2x squared minus 2x goes on the bottom. All right, we have two places where we can factor further, and that would be first numerator. So two numbers that multiply to give us negative 7 and add to give us 6 would be x plus 7, x minus 1. In the second fraction's denominator, we can pull out a GCF of 2x, and we're left with x minus 1. So once we do that, we can go ahead and start simplifying anything in the numerator with anything in the denominator. So the x minus 5s will go. X plus 3s will also go. And then comparing the two purple pieces here that I factored, you can also drop the x minus 1s. So your final answer will be x plus 7 in the numerator, 2x in the denominator.